All right, good morning. You guys are well this morning. A couple of announcements. First of all, there's no school on Monday. So, no school, don't go to any meetings. It's Labor Day. Also, you are going to have exam 1314 on Tuesday morning at 8 o'clock. All right, now, so that I don't get ahead of my other Algebra 2 classes, we're not going to have our regular class on Tuesday. In other words, you're going to take the exam at 8, but you will not report at this time. So you might see the meeting somewhere, but there's not going to be any meeting on Tuesday. Okay, so test at 8 o'clock in the morning on 1314, but there will be no regular meeting on Tuesday so I can get caught up and I don't get messed up with that Monday Labor Day. Okay? If you have any questions about that, ask me. So no classes at the regular time on Tuesday.
Is it going to be 2 tests or is it like just going to be
test? It's exam 1314, just like exam 1112 was. Okay, there's about 20 questions on. I should probably speak about this now too. I gave a pre-calculus exam and for example, my students wrote things like this because I told them that if it was a high power, they didn't have to multiply it out. And remember that a software program is grading your exams. So what the program wanted was students to work out this power, and give the long answer. And so I had about 20 students ask me to regrade their tests, and I did, and I gave them credit. So there were a lot of test grades that were raised because, yeah. So what I'm trying to say is if you think you did something right, you need to let me know to look at it so I can check it. Right? It's not going to be like, oh, we trust this software. Whatever the software does is, what we're going to go by. No, we're not going to do that. So we're going to go by what you're doing correct. And if you're doing something correct and the software marks it wrong, you need to fix that. But the only way for me to fix it is for you to notify me. Like, Ms. Burge, can you look at number 5? I think I got it right, but the software marked it wrong for some reason. Okay? All right, I think that's all I want to say. So what we're going to do today most of the time is just working groups on 1314. So before we get started though, I want to take any questions that you have. The other thing you should know is that this morning I put in the key for this sheet right here, the finding inverse sheet. I put the key in answers. So if you want to know the answers, the key is in there. I did it. You should really check your work because I have a feeling a lot of you did not learn this in Algebra 1 or you have questions about it, but make sure that you know how to do this. I'm talking about the sheet for 1-4. All right. Just to try to globally answer some questions here. And then we're going to work most of the period in the teams. So go ahead. Questions on 1-3 or 1-4? Does anyone have any questions about problems on this sheet? Finding the inverse. So there's no questions whatsoever. Nobody has any questions about anything. That's hard to believe.
Ms. Birch, can you do number 11 on the 1.4, the second page?
Is that in the book? Number 11?
No, it's on the pages that you gave us.
The sheet,
Yes,
the practice AB, or this sheet?
that one.
Okay. Okay, first of all, I don't know if you noticed, but the book is teaching it a different way than I am. So I had a few students contact me and say, what are we supposed to do? And what you're supposed to do is do what I'm doing. The book does do some weird stuff. And so I'm showing you the way most people in the world would do it and the most efficient ways to do it. So you always want to, if there's a controversy with me in the book, you can always contact me. But 99% of the time, I want you to do it the way I'm doing it, because it's either the best way, the most efficient way, or the way that most people do it and most teachers will do it in the future. All right, so that was number 11, right? So this is a function J. All right, now to find the inverse, you change the function notation to y. And when you have a long bar like that, see, you can't add 2. So adding 2 isn't going to do it. You've got to multiply both sides, and you're going to use parentheses like this. Now, I've seen some students put the 3 in parentheses, and that's just basically wrong. So I'm just letting you know that when you do this, and you do this, that's wrong. So make sure you watch your notation. Yeah, watch your notation. You always put the equation in parentheses. Okay, now watch what happens here. You're multiplying fractions. You can think of this as 3/1, but when you multiply fractions, you can cross cancel. So what you get is 3y is equal to 4x minus 2. Now add 2. We didn't switch the x and y though, right? We need to switch the x and y. So the first step in the steps I gave you, I told you to switch x and y and then solve for y, right? Sorry about that. All right, so in other words, solving for y means solve for the variable y, and it means isolate the y. And isolate means get it by itself. So what you're going to do is add 2 to both sides. Now, in solving equations, if you want to write this like this, let me get a new pen. You learned when you were in Algebra 1 to write this, and that's fine. But in Algebra 2, you want to wean yourself away from that at some point. Absolutely don't draw a bar. That bars mean division, so don't write a bar. Okay? So I'm going to allow you to do this if you want, but don't put a bar. Okay, so what I need you to be able to do is I need you to be able to look at this and go, when I add 2, I get 4y. When I add 2, you get 3x plus 2. Okay, now you're going to divide both sides by 4 in solving for the variable. So y, we're going to write as f inverse of x now. So that's the notation. And there's no reason to split this up. So sometimes students want to write this as 3/4 x plus 1/2, and there's no point in doing that. So if we were graphing, we would split it up. And you saw me do that the other day. But we're not graphing, so leave that alone. Okay, I do want to work a few more of these because I do not believe that most of you can do these correctly. So please ask me more questions on this. Go ahead, I'm listening.
Can you do number 8?
Do not put that X on the bottom. So that X is on the middle or the top, but don't put it on the bottom and don't make it look like it's on the bottom. All right, so we want to change the function to y. And the first thing we want to do is switch x and y. Okay, now, whatever's being multiplied to the variable, you act like he's his best friend. Don't give him first. So you're going to get rid of the guys on the outside. So you're going to add 1 and he goes away. And you're going to add 1 and you get that. Okay, now, remember what I said. You're going to want to put this in parentheses. Do not do anything different than this. If you do something different than this, it will cause confusion in the future. So don't do anything different. And plus, it's wrong. So just don't do it. All right, now, when you have a fraction as a coefficient of a variable, you can multiply by the reciprocal in one step to get rid of it. So what you want to do is you want to multiply both sides by 4/3. Yes, Miss Birch, but I don't like to do it that way. Okay, that's fine, but you're not doing it the best way. So I'm showing you the best way, the most efficient way to do it. So what happens here is these all cancel and you can write your F inverse of X. Okay, now you must distribute that 4/3. And that's why I had you write it in parentheses. Because if you don't put that in parentheses, you're going to fail to distribute. Because this answer is 4/3 X plus 4/3. There's going to be about 50 people that mess this up. That's too many people.
Miss Birch, why did it go from y to x on number 8?
Why did it go from y to x? Are you talking about this step right here?
Yeah.
We're finding an inverse, right? And aren't the steps of finding the inverse switch x and y?
All right, thank you.
Right? Remember the other day I put down, I gave you the steps of an inverse, right?
I think you did. If you did it in the 1.4 notes, yeah, you did.
Yeah, so the first thing you do is you change f of x to y, you switch x and y, you solve for y, and you change y to the notation of an inverse, f inverse of x. So make sure that whenever you find an inverse, you're following those steps. Okay, questions about this problem or another one?
Can you do 14?
Was that x divided by 5? And then plus 2? Okay, so we're going to change the function to y. We're going to switch x and y. And we're going to solve for y. And like I said, get rid of his best friend later. Get rid of the 2 first. So when you subtract 2, it goes away. When you subtract 2, you get that. Okay, so now how do you solve for y? You're going to multiply both sides by what? 5?
By 5?
So watch this. And this is where the 50 people are going to make a mistake. Right here. This is 5x minus 10. And like I said, if you didn't put parentheses in the appropriate place, you will fail to distribute and get the wrong answer. So I'm really glad you asked me about this one because there's going to be a lot of people that mess this up. All right, so what I want you to do right now is unmute yourself if you learned something in the last 2 minutes.
I learned something.
I learned something.
Yeah, I learned
something.
Keep going,
I learned something.
I learned
going.
I learned something.
Okay, so okay, good. So I'm really glad we got that cleared up. And I just wanted all of you to hear everybody that didn't understand this stuff. So the reason why I want you to know that is because I don't want you to be intimidated to ask me questions and sit there and go, well, I'm the only person that doesn't know what's going on. There's like a whole bunch of people that are in the same exact boat. So it's very important that you ask me questions to get this stuff cleared up. Okay, go ahead. I'm listening. Anything else right now? So right now, I'm just trying to feel some general questions on 1314 for the exam on Tuesday morning at 8.
How do you do 24?
On that same page?
Yeah.
'24. All right, change the function to y, switch x and y, solve for y. Change y to the inverse notation. What did you get confused about on that?
I didn't really know the first step. It does look easier than the rest, though.
Say that again?
I didn't know where to start, but it looks a bit easier than the rest.
Yeah, just follow the steps for finding an inverse, change the notation to y, switch x and y, solve for y, and change y to the inverse notation. Okay, go ahead. Other questions on 1-3 or 1-4?
Hold on. I think it was number 22.
On the same page?
Yeah, on the same.
Now, somebody asked me yesterday, do you have to show the transformational points on your scratch paper? And the answer is yes. If you don't show the transformational points, I have to assume you either talked to somebody or did the test with somebody or used the graphing calculator. So you have to show the transformational points to show me that you did them by hand. Okay, now what number was that?
22.
Okay. H of x, the function, they're called all different names, h of x, g of x, k of x, j of x. And this is what number is this? 22. X minus 4/3. All right, here we go. Change the function notation to y. Switch x and y. Okay, now, see that long bar? You don't want to add 4. In fact, you can't add 4. He's attached to this division. So what you have to do is you have to multiply both sides by 3 to get rid of that. So what you get is y minus 4 is equal to 3x. Okay, so when you add 4, it goes away. When you add 4 here, don't you get 3x plus 4? So would this be f inverse of x is equal to 3x plus 4? It's a linear inverse function.
Yeah, it was definitely the 4 that confused me there.
The 4, okay, yeah, were you trying to add it first?
Yeah.
You and about 20 other people. So I'm glad we went over that. So when you have a long bar like that, this is a quantity. It's all attached by that bar. So you can't get rid of the 4. The only thing you could get rid of is what is contained in the bar. You would want to get rid of 3. You cannot get rid of 4. So you can't. So if you would have added 4, you would have had to get a common denominator, and it turns into a huge mess. So yeah, can't get rid of 4. Got to get rid of 3 first. So as I was making the key for this, I was thinking, wow, this is a lot of problems, but I'm glad because you need the practice for this. So this practice is going to do you good because a lot of you didn't know how to do this. So it's good practice on solving simple equations. All right, anything else right now as far as 1, 3 or 1, 4 goes?
Can you do number 7 on practice AB?
Yeah, okay, now that's a verified problem. So let's do one of those. So they're going to give you 2 functions. The first function is g of x, and it's -5 minus 7 halves x. So that's a linear function. And then they're giving you f of x, and they're saying that f of x is -2/7 x minus 10/7. Now, those are both linear, so they could be inverses. Now, like I said before, if one's a quadratic and one's linear, they can't be inverses. Don't even do any work. Just write. There's no way these can be inverse functions because one's a quadratic and one is a linear function. There's no way. So don't do any work. If they're not both linear, both quadratic, both cubic, both absolute value, whatever the case may be. All right, now, what you're going to want to do for this composition is do f of g of x. And remember, you want to make sure it equals x. So you bring down the f function, you put the g function in. So the g function is -5 minus 7 halves x. Okay, see what you have here? You have f of x. So you have f of that stuff. So if you have f of that stuff, we need the f function. So the f function is 2/7 times something minus 10/7. Okay, does anybody have any questions right now? This is the f function.
Miss Birch, how did you get 10/7?
Here's the f function, right? I took the f function and I put it down here. This is the f function, right? I took the f function and I put it down here.
Oh, okay.
Right? So instead of putting x, I'm going to put our new x, which is -5 minus 7 halves x. Right? Or no?
Yeah.
Okay, so look what you have here. You have to distribute. So if you need to do this off to the side of your paper, you're going to do -2/7 times -5/1, which is a positive 10/7. You're going to then distribute. So a negative times a negative is a positive, and the 7s and 2s cancel, and you get x. So these cancel, and we do get what we want. Okay, now that's not good enough just to do 1. You have to do g of f of x. So you bring the g function down, and now you're putting in the f function. Well, what's the f function? It's negative 2 sevenths x minus 10 sevenths. Well, isn't that stuff the x of the g function? Don't we need the g function now? We need the g function. So what's the g function? It's negative 5 minus 7 halves times x. That's the g function, right? I see that or no? The g function. So we put in now what x is. So x is all this stuff, which would be negative 2 sevenths x minus 10 sevenths. Well, once again, you have to distribute. So a negative times a negative is a positive, and the 2's cancel and the 7's cancel, and so you get x. And then when you distribute over here, you also get a positive, the 7's cancel, and the 2 cancels with the 10 to get a 5. So yes, these are inverses. Now, if this was some other thing other than x, like if it's not x, don't even do the second part. It failed. So if this fails in the first part, don't do the second part. Okay, go ahead. I'm going to take questions on this problem because I know there's lots of questions. So go ahead and ask me.
For the f of x function, why did you separate it when you put it?
Here?
Yeah.
I'm not separating it. All right. Can you guys see that we're dealing now? We put the g function in, we're dealing with the f function. See it? So the f function is negative 2 sevenths x minus 10 sevenths. Does everybody agree with that? That's the f function, right? What you see me do is you're seeing me take this x out and put this quantity in for x. So that's why you saw me write it like this. Because this was the x and I took it out because I'm going to put this in. Did you follow at that time?
Yeah.
Okay, go ahead. Other questions?
So on g of f of x, the 7 over 2 and the negative 2 over 7 equal 1, right?
Yeah, so this, I'll show you what I'm doing. So what I'm doing off to the side of my paper is I'm taking negative 7 halves times negative 2 sevenths. And remember, when you multiply fractions, you can cross cancel. And that's how I'm getting a positive 1x. So I'm getting a positive 1x. And then on the second part, you have negative 7 halves times negative 10 sevenths. And it's okay to do it off to the side of your paper. You should do it in the margin. Don't do it in line with your work. So this would be a negative times a negative is a positive. The 7's cancel, and 2 goes into 10 5 times, and that's how I'm getting the positive 5. So when I'm distributing this, I'm multiplying fractions. That's what I'm doing when I distribute here. I'm just not showing it because it's easier not to show it. You know, it's easier to say, okay, we're multiplying two fractions. A negative times a negative is a positive. Cancel the 2's, cancel the 7, 1x. Over here, a negative times a negative is a positive. Cancel the 7's. 2 goes into itself once. 2 times what is 10? 5. So it's just easier not to try to do this. You can do it though if it helps you off to the side of your paper. I don't want to see this though. So you can do it off to the side, but don't do it in line with your work. Same thing with this. See how off to the side of my paper, I took negative 2/7 times negative 5 over 1. Nothing canceled. So you multiply straight across, positive 10 over 7. Okay, anything else before I erase this? I can erase it. When you have a monomial, a single term sitting on a binomial parentheses, don't forget to distribute. And remember that the distributive property is a multiplication property. You're not adding, you're multiplying. Okay, so we haven't worked a lot together in the Math Wizard teams, but we will be. It's just that initially with class starting, I have to go through how I want things done, assignments, notebook, how I, how to get into these groups and everything else. So we will be working in the teams more, and I will be switching up the teams. You will not be in these teams all year. So listen carefully what you're going to do. In Google Classroom, I have the Math Wizard teams. I'm going to be taking attendance throughout the period and dropping in. What I want you to do is you are going to study for the 1-3-1-4 exam. All right. So I don't care if you work the problems 20 times, you're going to work them again. And what you're going to do is you're going to take turns working problems and answering each other's questions. So both parties, the people that understand what's going on and the people that are confused, both parties benefit from this. Because the people who know what's going on, to be able to put your thoughts in words is going to be beneficial when you go into the workforce. And it's also just beneficial because it means if you can put it into words, you don't have to study as much. And the people who are confused about stuff, you're going to benefit from asking questions. So you are not to work independently. You are to collaborate, pick problems, take turns picking problems, working the problems out loud. Okay, so I'm going to try to train you as I come into the classrooms if I don't feel like you're doing that. Also, eventually with these teams, you do realize you can set up your own Google Meets with people and you can share the screen of your online textbook and practice online problems. So that's going to be a very powerful thing if you can set up, your own meetings and work together on those types of problems, because those online problems are what your exam looks like. All right, so we're not gonna, so let me just tell you, so class today ends at 10:45. So you have 45 minutes, because it's 10 o'clock right now. So you have 45 minutes to take advantage of this time. You are not to leave class early. I will mark you absent. So at 10:45, you may leave class. Okay? All right, does anybody have any questions about anything? All right, I'm going to turn off this recorder and I'm going to actually get out of this meeting. If you need me, just send me a reminder. I can come into the group. Otherwise, I'll be dropping by all the groups and see how things are going in your collaboration. Okay, anybody have any questions? I'll see you in your teams. Okay, go ahead and go to your teams. They're in Google Classroom. So take a look and go into your teams.
Do we leave this meeting?
You can leave. You can leave this meeting. Yep.
All right. Take care.
Okay, I'll see you in your teams.